Okay, I better turn the music off. YouTube don't like playing songs on that are copyrighted, so I need to turn that off. I'm sitting out here rocking out. I got my material started here. I cut, this is for the disc again. So now I got a little end mill. I'm going to part off pieces here, and then I'll end up drilling the 2 holes in it, one for the crank itself, and then the throw over on the side. But anyway, I need to get 4 pieces out of this. I'm hoping that I can do that. I got a little end mill in here, an 1/8 incher. I'm just going to hack them off of that, I hope. Let's see if I can bring this down. I think what I'm going to do is make sure that the end is square first. I'm just going to run it across the end here first, just to make sure that that's square to the world. Looks pretty good. Alright, I got a scribe mark on there. Move it out beyond the scribe mark. And I'll take I'm just going to eyeball it. I'm just going to eyeball it a little long. Like right there. Alright. Drop it through all the way. I'll cut them to the length, finished length afterwards. Okay. One down. Got a scribe line on the other side here. We'll do the same thing. Like I say, I'm going to finish them to length afterwards. Stick that out of there. And now I want to take the part that I just cut off, put it on the other side of the vise, being that it's getting pretty close to the end. I don't want the vise tilting and then the part coming out. So always keep something the same. If you're just using the edge of the vise, make sure you got something on the other side that's the same width. You know, that way you can rest assured that it won't come out of the vise. Otherwise you run the risk of it coming out of the vise. Drop it down and hack it off. Okay, put another scribe line on there. 911. I'll scribe it. I'll put a couple scribe lines on here again so I can see where I gotta go to. There, I put a scribe line there and there, so I can just eyeball it to that. Raise it up a little bit. Okay, so now what I'm going to do is I'm going to go ahead and mill them to the length that I need, and then I'll end up, like I say, I'll end up drilling a hole. Let's see, it goes this way, so it would be a 1/8 inch hole through here and the 172 threaded hole over here, and the first operation over on the NC machine, I'll put it down in my soft jaws, just plop it in like that, and it'll come in and mill this configuration. Then I'll take a plate and put pinholes in for the crank and then that 172 and load it on those. I'll be able to clamp out here and out here with a little tiny clamp and then mill the cam. That's the plan anyway. We'll see if it works. So anyway, I'm going to go ahead and mill these to length. So, and I'll get the holes drilled, and when I get over to the NC machine, I'll come back. Okay, this is going to be the first attempt, and hopefully everything goes well. You know what, I think I'm going to take, and I'm going to dry run it. I'm going to take the part out, just loosen it up just enough to get the part out. Like that, and just leave that sit right there. And now that kind of wiggles. I think I'm going to put an adjustable parallel in there to hold that at that distance, so that I can tighten it up so that movable jaw doesn't wiggle. So I'll take it, put an adjustable parallel in there. Oops, wrong way. Slide that in there. I need something, I need a screwdriver. The screwdriver to reach down and adjust it. Well, I can put it this way. Duh. Just put it over on the side here. And then tighten that up so that this jaw, the movable jaw, doesn't wiggle around and wreck my end mill. Okay, so here we go. First time through this program, I ran it on the graphics. It looked good, so we'll give her a go here. Oh, I need to turn the spindle on. I usually turn the spindle off physically, so that when I'm messing around, it can't start accidentally. I'm going to slow the feed rate down. Slow the feed rate down a little bit. I don't know if I need any coolant on it. My air nozzle is wrapped around the tripod, so I can't move it too well. What if I can turn this way? That help? Yeah, I could have left the feed rate alone. I slowed it down. That's okay. I'm not in a hurry. As long as it does it right. I haven't ran or done any programming or run my NC probes. Man, I'll bet 4 or 5 months. It's been a long time. I can't remember the last time okay, we went into the finish pass. Finish pass is a little faster. So far, so good, as long as I don't have any surprises in the end here. Should pick up right about here somewhere. And move back to 0, and done. Just blow that off, take a look at it. Let's see here. It looks pretty good to me. I don't know if you guys can see it at all. Move the camera over here maybe. Take a look. You can see it right here. So now I can go ahead and put a part in there. It looked like it ran really good, really well. So I'm going to take this adjustable parallel out of there. Put the part back in. Make sure I load the part with a little 156 hole toward me, toward the front of the machine. Slide it in there, slide it up against the... I see the stop is gone on the one side because of the... But that's okay, it's on the bottom side here, which will be good, plenty good enough. And what did I do with my vice handle? I opened it up with the wrench. There you go. Put it back here. Just snug it up a little. Here we go. This one's going to be for a reel. Let's see. I need to lower you down. You're not quite seeing that. There we go. Alright, here we go. This one's going to be for real. I'm not going to mess with the feed rate or anything. I programmed it on the safe side anyway, and had overridden the feed rate in the program a little bit to slow it down. Still, I don't know if I really need coolant on this. Get my brush. Then I'll have to make a little fixture to hold it the other way upside down, but I'm going to load on the 2 pins, or the 2 holes. The crank hole and then the 156 hole. Ta-da! Alright, let's take it out of there and see what we got. Okay, this is what we got. And Now the next operation would be to flip it over and then run the cam side. So it hasn't been deburred obviously or nothing, but it looks pretty good. So we'll load the other three up and do the same. When I get to the second op, I'll come on back and give you a look at that. Like I say, what I'm gonna do is I'm gonna put it on a 1/8 inch pin for the crank. I'm gonna thread in a 156 diameter or 156 screw, and I'm gonna have a hole in the fixture that'll slide into. It'll be a nice slip fit to the 156 thread, and that screw will locate it, and then I'll have two little clamps to come on top here and clamp it, clamp it down on the CS and the front, and I'll just barely catch it, and then I'll leave room for the end mill to get through and mill the cam. That's the plan anyway. Whether it works out or not, we'll find out. So we'll catch you later. Okay, I got the little fixture done on my plate over here. What I did was I drilled for 1/8 inch dowel pin, and then I drilled a small hole for the 172 thread, a clearance hole. I'll zoom in over here for you. Trying to take a look. I haven't ran apart yet. That's what it looks like. It's not much to see. It's just a scrap piece of metal, and I just went ahead and drilled a hole for an 1/8 inch dowel, and I drilled a clearance hole, and I'm threaded a long screw into the part, so I can put that down into the hole here. Basically it clocks it, and push that down in there. And how I'm going to clamp it is I drilled 10/24 screws on both sides, and all I have is a bolt with a couple washers on it, and I got a little spacer, a pin, just an old pin that I'm going to put under the back side of that washer. Cat's driving me nuts. He wants his supper, and it ain't supper time. Okay, so that washer is going to catch on top of that little screw that I have in there, and it's going to tighten down on that, hopefully. I don't need it real tight. And then the same thing over here on the back side. This washer is going to catch the edge of the part, and I got a little spacer. It's not quite the same height, but pretty close, and it'll just tighten down and catch the back of my part. If I can get the thread started here. I haven't set my Z or anything. The only thing that's set is the location. I've got the location. It's set 0 is over the location of the 1/8 inch dowel. So we'll just snug that up. So I'm going to move over and then pick up 0 on the top of that. I have another camera set over here on the side. At the end of the video, I'll give you the perspective of the other camera. I'm going to turn that camera on so we can kind of see what's going on. And get it started here. Come on. There we go. Okay, so the little one's recording. I think I'll turn this off. Sometimes that helps when I'm videoing. Okay, so now I'm going to move off center of that pin, so I'll just jog out a little bit, and then I'll crank the table up. I got an 1/8 inch end mill, 3 flute in there. Probably off screen here now. And I'm going to bring the quill down a little bit. Okay, that's about as far as I'm going to go with the quill. I don't want to go any further than that. And then get a piece of my phone paper off of my piece back here. Crank it up here. I use my phone book paper for touching off like this, and it works out pretty good. Alright, so that should be 0. I'm going to 0 out my Z since I moved my quill down. And now I will jog that back up. And we should be ready to go now. Alright, I'm going to, I don't know if I'm going to turn the feed rate down or not. Can't get any close, zoom any closer, it goes out of focus otherwise. So, here we go. Take 1. And I got to turn my spindle on. First one so I can see what's going on here. Make sure everything is going to work out alright. I don't know if that's better with the light off or the light on. I must have took it in two passes on depth wise. I thought that I took it all in one, but apparently not, because I see that I'm not down to my depth. I don't remember. I wrote this program a couple days ago when I posted that the video of it, the simulation. There we go. That's looking good. Should take a pre-pass or a cleanup pass now. About 20 foul cleanup pass. That's kind of a heavy cleanup pass. I should have probably only went 10 since I'm climb cutting, but looks like it's working all right. Should be done. Ta-da! Alright, let's jog that out. We'll jog it out of here. And we'll grab the vacuum hose. A little bit of a squirt of air. And we'll take that off of there and see what it looks like. If I can find where I laid my Allen wrench. Here we go. Then the only thing after this is to drill and tap the hole, the threaded hole for clamping, or for putting it on the crank. Jog back a little bit further. Okay. That's it looks pretty good.
blended to the floor. I got maybe a thou mismatch there. I think I could crank the table up. Let me mic it with my mic and see. I might just run this one around again to take and get that get this mismatch down to where it should be. This is okay. One. 2 thou mismatch. I'm gonna go for it. 1, 2, and I'm gonna put it back on, and I'm gonna do it again. A 2 thou mismatch. If I hit it with a file, you probably wouldn't even know it. You wouldn't notice it unless I told you. But I would. I don't know. Well, I'll probably buff these. I'm gonna powder coat the main frame of the motor, I think, and the rest of it I'm gonna either do a little polishing on or cat's probably driving you guys nuts too. He doesn't quit once he starts. He just continues. Alright. Let's run her again. Couldn't cut anything until the second pass around. First pass up in the air. I could have probably just took that pass out of there too. Oh well. Like I say, I'm not in a hurry. Yeah, we're all taking a little bit. Should be taking about 2,000. And then move in for the finish pass. And done. Okay. So, it's looking good. I'll run the other 3. I was playing around with flywheel program. I took a program that I used for my ring bomb engines and just modded that a little bit. So I think that's going to be my next part. Oh yeah, that's much better now. So anyway, it looks like what I want, so I'm gonna go ahead and run the other 3, and then when I get material and stuff going for the flywheel, I'll come back, and that'll probably be on another video. That'll be the next part to do, because this part, well, actually no, I gotta set up and drill this hole back here, so I'll probably come back when I set up to do that. So anyway, until then, catch you later. What I'm doing is I set it up on in the vise. I set it up in the vise there, and I got a stop set. Let's move over to this side over here. Move you over to this side, and I'll turn that light off. Now can you see it? Anyway, I set it up, and what I'm doing is I got a stop set, and I got the dimension over, and I'm just eyeballing it with the back edge of the jaw. So I just come in here and do a center drill. A real small center drill. And then a number 53 drill is what I'm using. Drill the hole. Then I have the tap set up in a just like a little thumb. I use that on all my real small taps. I put some Molly D on there on the tap. I put it up in the drill chuck and just lightly clamp it. Come down and touch and then lock it off, and then I just crank her through. It's sliding, and the drill chuck is holding it from bending or breaking. That's 9 times out of 10 when you break a tap, it's because you've pushed it off center. If you keep it on center, they get pretty dull, and you can feel how dull they're getting. And knock on wood, I've had pretty good luck doing it this way in my career. Okay. Take it back out of there. Oh, it is out. Drill chuck was it. So, the hole's drilled and tapped. Looks good. So I will do the rest of them. And that's going to be it for today. When I come back, I don't know if I'll get out here during the week or not, depending on what's going on around the homestead here. I hope to get out here, but I do have, I think, a program pretty much done for the flywheels. I'm going to make them similar to the flywheels that I made for my ring bomb engine, and I'm going to just mill those out of some 1/2-inch aluminum blocks, and once I mill them out, I'm going to use the NC again. I'm going to mill them out, rough them out on the mill, and then I'm going to take them over to the lathe, and I will probably clamp them on an 1/8-inch dowel, and then finish turn them so that they run nice and true. And plus I have to put the recess in on the back side. I'm not going to do it on the NC mill. I could. Maybe I will. I haven't given that much thought yet, but I am going to true them up on a lathe. That way it takes any of the wiggle out and makes them run nice and true. And then after that, I'm not sure what part I'll work on next. I don't have a whole lot left. I've got the fork and roller for the cam follower, and the piston. Got to finish that. Piston rod. Well, connecting rod. That's what I'll work on next. Once I get the flywheel done, I'll write a little program for the connecting rod, and I'll do that. Since I'm playing on the NC, like I said, I haven't used my NC machine in a long time, and it's kind of fun playing around with it. Not doing anything big, but it's more than capable of end mills down to I'd say down to 16th, because I can run 6,000 RPM, 6,000 RPM. I do have a high-speed spindle attachment that I made for it that I can run. Oh man, what is it? I think it was 18 or 25,000 RPM. It's what it is it's an attachment that holds a Dremel tool, and I've had really good luck with that for cutting sheet metal parts and gasket material. So, and I haven't had that on there since I cut head gaskets for my little Demon V8. So maybe I'll have to think of some kind of project to do to use that again. That's kind of fun to crank it up, and I turn the spindle off on the mill, and then I have it the Dremel tool plugged into my coolant. So when it calls for coolant, I can turn either the coolant on or the Dremel tool, and I just turn the Dremel tool on, let it run. So the console actually controls I put a box on my mill a while back, a control box, because I wanted to have more control on my coolant. So I can switch from flood to air blast, and I can switch from manual to console, you know. So it works really well. And then they go to this plugins, so I can just unplug this, plug my Dremel tool in there, and this power box or outlet is either for the flood or this one's for the air blast. So if I plug the Dremel tool in on this air blast right here in front and flip this down and hit it on console, the Dremel tool will turn on and off by itself, and I like that. It works out pretty good. My power feed for my lathe, I've been using that quite a bit, and I mounted the box up there, and I've got it set so that it comes on and off with a spindle. So I say that little project was a success. I really like that, because you don't have to stop and switch gear or mess with the gearbox if you want to change your feed rate. Works really well. So if anybody's thinking about doing that to their lathe, I highly recommend it. Whether you do it this way or there's a lot of different ways of doing it, and I've seen a lot of different plans on the web. I went with my own little take on it. It works really well. So Portland, Oregon that I'd like to go to too. So anyway, that's enough jabbering for now, and we'll clean up my mess and call it a day. So thanks for watching, and we'll catch you guys later.